Hello everyone, for this tutorial video, I'd like to explain what the cross product is, which is the other main type of vector product, which returns a vector answer rather than a number or scalar answer. In particular, the cross product is A cross B equals second component of A times third component of B minus second component of B times third component of A. For the first component, third component of A times first component of B minus third component of B times first component of A. For the second component, and finally for the third component, first component of A times second component of B minus first component of B times second component of A. This may seem a lot to handle at first, but actually makes sense if you know that the cross product is a cross of two vectors. And we can also see it is called the cross product because you are cross multiplying if we diagrammed out the vectors and their components using something called a matrix, which looks like this. So we can see the cross product is the components crossing over along diagonal lines, like so, when we draw diagonal lines on the matrix. If we are asked to figure out the cross product of A and B, and the cross product of B and A, and we are given all three components for A and B, we would see, after all the computations are done, that the two products give generally identical results, but one is the negative of the other. So the first term has a negative sign while the second term does not. Before we come up with a more general conclusion from this though, we will stop and define the geometric definition of the cross product as magnitude of A times magnitude of B times sine of angle, just like the cross product was a cosine instead. This means if two vectors are parallel, the cross product will be 0, so we know the magnitude of the cross product must also be 0, because the only vector that is 0 for all of its components must have 0 length. Knowing this, we can next state that if the cross product is not equal to 0, then the cross product must be orthogonal to both A and B. We remember what we saw earlier, so we can state a more general formula for when you reverse the cross product is that cross product of U times V equals negative cross product of V times U. And we can also state by the distributive property that the cross product of a vector and a sum of vectors is the sum of the cross product of the distributive vector times the individual vectors. And just like with the dot product, we can factor constants out of cross products as well. And we can derive general formulas for dot products and cross products related to each other. In particular, the dot product of one vector with the cross product of two more vectors can also be thought of as the cross product of the vector you are distributing with one of the vectors in the original cross product, and then the dot product of that with the other vector in the cross product instead. Because of the fact the distributive property works the same way for cross and dot products. And we can see the computation / matrix for this is similar to the original matrix, except instead of the generic I, J, and K, we have the three components of the U vector specifically. Now that we've figured out what a cross product is, we can use the dot and cross products to figure out special 3D vectors such as tangent and normal vectors next. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.